I'll launch it first. So what we did yesterday, I think we had a look on basic IP routing, so IP routing concepts like routing, switching, uh, and get relation, right?
Mhm.
So let's move further. Now, today we'll talk about other parameters that a device considers to find out the best path to reach a destination. So let's say we have, what if I have a packet that is trying to reach, let's say source is 1.1.1.1 and destination of the packet is 2.2.2.2. Okay. We have a few routes in our routing table. We have 2.2.2.0 slash 24. We have 2.2.0.0 slash 16. We have 2.0.0.0 slash 8. And I have 2.2.2 slash 32. I have 4 different information in my routing table. So can you tell me to forward this packet, which entry would be taken by the device? Which route will be preferred by the router to forward the packet which has a destination address of 2.2.2. Yes, guys, is it the first one, second one, third one, or the last one? Put your answers. Okay, so Anjum says the last one. What about others? Okay, Janardhan also agree with Anjum and he says last one. Ali and Sayed, what about you?
Last one.
Okay, so we are going to choose the last one. Now, another question you have is in routing table, the routing table that we have, we always put the best path information, right? So, which route will be installed in the routing table? That is correct, that to forward this packet, the last route will be used by the router because that has more bits in common compared to your other routes in the routing table. So basically, the best path selection process that the router follows is gonna be, the first thing is the longest prefix match. Okay? The longest prefix match, and then if that is same, then we come to administrative distance. And if that is also same, then I will the metric. If all 3 parameters are same, I'll do load sharing or load balancing. Means I will install both the path or multiple paths into the router. So let us say right now again I'm saying 2.2.2.2, putting the again same information 0.0.0.0 slash 8 slash 16 slash 24 and slash 7. In routing table, as you know that in routing table we are only going to keep the best path, right? So among these 4 routes, which path is going to be installed in the routing table, guys? Is it the first one, second one, third one, or fourth one, or all? I'm not talking about any IP packet forwarding. I'm just asking you that in case a router is learning about these 4 different routes, which route will be installed in the routing table? First one, second one, third one, last one, or everyone? Okay. So Anjan says the last one. What about you, Ali? Yes, Ali. Ali, can you hear me? Okay, Ali is not available. Sayed, guys, can you hear me?
Yes, sir.
Yes, Janardhan. Which entry will go into the routing table? Janardhan? Okay. So Janardhan says second. Here, see this. The answer is all. Okay, the answer is all. In case you learn 2.2.2.2 slash 32 slash 24 slash 16 and slash 8, remember here these all 4 entries, these all 4 routes are different. They are not same. Remember this. They are not same. When you are considering the prefix length in these routes, we have slash 32, 24, 16, and 8, which makes those routes as different. They are not same. So when those entries are different, you are going to install everything into the router table. So not the first one, second one, third one, or the fourth one. Router is going to install all 4 paths into the router table. Okay, because slash 32 is telling me about something, slash 24 is telling me about something totally something else, slash 16 can tell me about totally something else, slash 8 would tell me about something else. They are not same. Remember, routes are considered to be same when prefix, remember, prefix and prefix length, both parameters are same. Okay, when both parameters are same, then only routes are considered as same. So it will never come to administrative distance metric or anything, because here longest prefix match is not same, right? In this all 4 routes, all 4 information are going to be installed in the router table. Remember this. Okay. So other parameters like AD value, metric are going to be considered only when you have prefix length as same, prefix as same, and prefix length is also same. Like somewhere when you learn 2.2.2.2 and 2.2.2.2 slash 32 slash 32, this is when you learn this two information via 2 different paths, then the administrative distance will be considered. Okay, and that is going to be by a different routing process. So now let me give you one other example. Let's say we have I have learned 2.2.2.0 slash 24 and 2.2.2.0 slash 24. This was learned via RIP and this was learned via OSP. Okay, so first of all, the longest prefix match will be preferred, right? So here you don't have a choice of longest prefix match. You cannot determine here that which path is going to be best because based on longest prefix match, because both the longest prefix match, both the prefix length is same, slash 24 and slash 24. So when you learn two paths for the same destination with same subnet mask via two different routing process, I'm learning one via RIP, one via OSPF. Here the AD value parameter will be considered. Okay, AD value parameters are considered when a router learns multiple paths with for the same destination with same subnet mask. Then the AD value parameter dictates which routing process you need to believe. So administrative. So first of all, I'll write down about prefix length, longest prefix match. Before considering any other parameter, for the best path selection, a router will consider a path that has most bits in common with the destination IP address. Okay, so you get this point, longest prefix match. That means if I have a slash value 2 route and that is having all the matches to the destination IP address, I'm always going to prefer that. So slash 32 will be preferred over slash 24, slash 24 will be preferred over slash 16, slash 16 will be preferred over slash 8. Okay, remember why you need to prefer that, because that is giving you more information, more specific information, guys. Okay, if I tell you an example, let's say you all guys have a few of your friends in India. Okay, for the people who are not from India, let's say someone is telling you, no one is from Bangalore basically. We have our networkers home in Bangalore and we don't have anyone here who is from Bangalore. So let's say you guys, all of you guys have 4 different friends in Bangalore, and one of the friend is telling you about networkers home. All the friends basically they are telling you about networkers home, and one of the friend is telling you that networkers home is in Bangalore. Another friend is telling you networkers home is in HSR layout Bangalore. Another third friend is telling you networkers home is in sector 6 HSR layout Bangalore. Then the next friend, the last friend is telling you networkers home is in building number L165 sector 6 HSR layout Bangalore. Now, which friend of yours is giving you more specific information, more detailed information about networkers home? That is obviously the last one, because he is giving you the perfect specific match to the destination, that is networkers home right now. So remember that is the reason why always 2.2.2.2 slash 32, in case you have a package that you should forward to this destination of 2.2.2.2, you should always choose if you have slash 32. If you don't have slash 32, then whatever is available, you have to take that. So that is available, you will match this. So this. So did you understand, everyone? This is like when you say 2.0.0.0 slash 8, this is like the friend who is telling you networkers home is in Bangalore. That's it. This is like you can compare that networkers home is in HSR layout Bangalore. This is sector 6 HSR layout Bangalore, and this is the exact match to the destination. The building number, sector 6 HSR layout Bangalore. Okay, that is the reason the router will not consider AD value or metric parameter before the prefix match, the longest prefix. Okay, the router will always take a path which has most binary bits in common. everyone should be clear with this. Guys, if you have any question anytime, you can just stop me and post your answer in chat, or you can talk to me, okay? Anytime, anywhere, you can just stop me to ask it out. So coming back to this, now longest prefix match was done when we were learning multiple prefixes, right? When we were learning /32, /24 and all that. Remember, for packet forwarding, we will be considering /32, but if the prefix length is different, in routing table, I'm going to install the both part, all the parts. Okay. Now coming back to this scenario where I have a RIP route and O route, which is OSPF route, and I'm learning same network with same subnet mask. When I'm learning same network with same subnet mask, then I cannot decide that which path is better based on what prefix length I should choose. Okay, based on longest prefix match, I cannot decide that which path to choose. So here, when you learn multiple paths to reach the same destination with same subnet mask, then the AD value parameters are considered. RIP has a default AD value of 120 and OSPF has a default AD value of 110. So remember, AD is always lower is better. So here you can compare 110 and 120. These are the default AD value decides on they have already been decided based on the behavior of the routing protocol, how trustworthy the routing protocol can be for a router. So based on that, these are default, but if you want, you can change those things. So you can compare 110 is better than 120. So definitely O route will be preferred over FF. Okay. So I'll write down the note about it. So here, administrative. Okay, you can note down that when a router learns multiple paths to reach the same network with same subnet mask via multiple routing process like RIP, OSPF, PRG, then router is going to consider always the path which is having the lower AD value. So now the AD value parameters are considered in case you learn multiple path for same network, same destination. So if I have 2.2.2.0 slash 24, 2.2.2.0 slash 24. So I'm learning this via D means CIGRP, and this is via static. Static has AD value of 1, D has a AD value of 90. So you can compare all of them. If I'm going to compare with AD value parameter, I will always choose the path with 1. Okay, so that's what AD value parameter does here. So I'll write down the default AD value parameters for different routing process. I'll start with connected. I'm writing down the default AD values for different routing process. So if a router learns a connected route which is directly connected to a router, it will always have 0. Static.
Hello, Pawan. Hello.
Yes, I'm here. Okay, so these are the default AD values that we have by default for these different routing process. You can note down. Now after this, what if I have here 2.2.2.0/24, 2.2.2.0/24, and I'm learning this path via RIP, and this path is also learned via RIP. So now the first parameter, prefix length is same, and because both the routes are learned via RIP, the AD value parameter is also going to be same, which is 120, right? Now what parameter we need to consider to consider the best path among them? Then we have the metric value. So let's say this I'm learning via 5 and this I'm learning via 4 of metric. So different routers, different routing protocols uses their different calculation of metric. Okay, so metric is also lower is better always. Lower is better, right? So here always the 4 will be preferred over 5. So when a router learns multiple paths to reach same destination with same prefix length with same AD value, then the metric parameters are considered, and lower is better. And different routing protocols use their own calculation based on different parameters to calculate their metric. Okay, so we have this metric parameter which will be considered in case same same routing protocol is advertising two paths with same prefix length for the same network, then the metric parameters are considered. Okay, these are basics of IP routing, guys. You need to understand this because no matter which routing protocol you're going to use in future, you are always going to, the router is always going to take decision based on this order. So first, longest prefix match, after administrative distance, after that metric value. Now if all three parameters are same, then a router installs all the path into the routing table and does what? Load share. Okay. So up to this point, guys, any question? Anyone? Anjum, Sayyid, Janardhan? Any question? You guys are with me?
Yes, Pawan. No.
I didn't get this metric value.
Metric value, okay. See, metric value parameters are considered when as please turn off your mic. Please mute yourself because I'm getting my voice back. See, I told you that when a router learns, let's say a router is learning about 2.2.2.2, 2.2.2.2, or another route. Let's say I'm learning 4 different routes. One is via RIP. This is also via RIP. That is also via RIP. And this is also via RIP. Okay. So when I'm going to learn same network 2.2.2.2 with same subnet mask, let's say all R/32 routes. Okay. When I'm learning same network with same subnet mask via same routing process, maybe it's a RIP, maybe it's OSPF, maybe EIGRP, any of the routing protocol that I'm going to use. If I'm learning multiple path to the same destination with same subnet mask via same routing protocol, I'm going to consider the metric parameter. Okay. So the example which I took first, that was 2.2.2.0/24, 2.2.2.0/24, which both were learned via RIP. One I was learning with a metric of 5, and second I was learning with a metric of 4. Right? So always lower is better. So router will always take the path with the metric of 4 here in this.
No, I mean, how we got this 5 and 4 value?
That 4 value is basically depend, as I told you here on the notepad, that all the different routing protocol are going to use their own calculation to consider their metric. Like in RIP, we use the hop count. Okay, so the number of hop you are away from the destination, that's what this 5 and 4 represents, which we will talk in much more detail when we will talk about the routing protocol RIP. Okay.
Okay.
So let's move further, and now I will start the static routing here, because we have already discussed about the basic IP routing, right? How the router chooses the path. So whenever, remember, I will just take a review from yesterday's class. Whenever a router, you assign an IP address, whenever you assign an IP address to a router's interface, any of the interface, that router is going to install a route in its routing table for that network connected to that interface, right? So when you go to R1 and say interface fast Ethernet 0/0, and you're going to put, let's say, 10.1.12.0/24, enter. And when you put no shutdown command, after that, when you enable that interface, router installs a route into its routing table. Because how the routing table entries are built, we need 3 information for that. First is the network, second is the prefix length. So network is called as prefix, and prefix length is the subnet mask. Then the third information that you need to make a routing entry into the routing table is going to be the next hop IP or the exit interface. Okay, so each routing entry in your routing table of a router is going to be built using these 3 information. You need to know what network it is, what subnet mask it has, and the next hop IP or the exit interface information you need to have. These 3 information will be used to make a routing entry into the router. Okay. Now, I told you that whenever you install an IP address on one of the interface of the router, that router is going to install a route for that interface. So like if I take a review from yesterday's class, I said interface F0/0 I said IP address 10.1.12.0, 10.1.12.1, some IP address 255.255.255.0, and I said no shutdown. After this, as you know, remember the network, prefix length, and the next of IP or exit interface we need to have. So when you put IP address, router is going to install a connected route, and that connected route is built up of these three information. The network information is taken from the way you put your IP address. So you're putting 10.1.12.1 with a /24 mask. That means first three octet belong to the network part. So that's what we are going to install, 10.1.12.0, right? And the next information is going to be prefix length, which will be taken the way you have, again, you have assigned the IP address. So when I was assigning the IP address, I put /24. That's what is going to be installed, /24. And via, we need another information, next of IP or the exit interface. So which interface I was putting this IP address on? F is /0. So that will be via F is /0. We have all three information, a routing table entry is built. So here, now what I've done in this GNS3, you can see I have 3700 series device, 7200 series device, and I have IOU router. So what I've done, I've integrated the IOU platform with my GNS3. Okay, this 3700 series is the 12.4 iOS. Here 7200 series, if you want to use the latest iOS that Cisco asked you to do for your new CCNA, CCNP, CCI certification, that's going to be based on your 15. Series operating system. That is possible only if you use 7200 series device with 15.x iOS. And with that, I have also included in GNS3, I have integrated the IOU platform, which you can see I also have IOU devices. This is not going to start right now because for that I have to start the virtual machine. What I've done is I've installed my GNS3 VM on this virtual box, okay, and that VM is connected to the GNS3 that I have integrated into the GNS3. So for that, with this, what you can do, you can actually do whatever you were doing into the IOU platform previously, which was VMware based. I'm using this virtual box, and now I can also pull in GNS3, same window, I can pull this IOU switch, which you can see, and I can just connect that with these devices, and that works fine. So I'll make a topology with that using that switch.
Do we need to buy the license to install this?
No. I'll share. No, you don't need to buy anything. We can actually make with the notepad file. We can make the license. I'll send you the detail. So if I take this, there is a little bit configuration that you need to make with GNS3 and that virtual box. You need to install that. So here I'll just log in. Root. Don't worry, I'll share the information with you. I'll record a video on this specific thing and I'll share with you guys. Okay, and all the things that are required to build this, I'll give you. So that you can.
What is the difference between the normal iOS and IOU VM?
The difference is this is also Cisco's proprietary. Basically, what used to happen here previously, we in GNS3, the switching is not possible, right? So switching we cannot simulate. So we have to use some other platform like this IOU on VMware we used to run, and there we used to make our topologies to use switching. But remember, this IOU is a Cisco proprietary. Cisco came up with this IOU, and this IOU is nothing but that operating system, inter-network operating system, Cisco iOS on the Unix platform. So the difference is this iOS images that you are going to run in GNS3 platform are the normal iOS, and on that IOU platform you have this images. If I take you to the web browser, that IOU platform runs different iOS images, which are specifically designed for your Linux platform. So I'll take you to the URL is 192.168.56.101. This is the IP address of my virtual machine, and it is listening on port number 8000 and upload. I'll just show you what are the images I've added. So you can see here on the screen, I have uploaded two images to this. One is the L2 image and one is the L3 image, and both are, this is 15.1 and this is 15.4. This is I'm going to use for the routers, and this is I'm going to use for the switches. So this is the specific iOS image for Linux platform. That's the difference. Okay, so here now, once your virtual machine is started, you can log into that, and then you can open your GNS. And now here I can actually pull those devices. I'll just delete these devices and I'll pull those IOU devices. So let me take this IOU switch here and 17200, which is going to run just the normal GNS3 iOS platform, and one IOU device and one more IOU device. Okay, now we'll take a cable. Fast Ethernet 0/0 will be going to 0/1, 0/2 will be going to IOU2. Remember, still only Ethernet interfaces you can use, because this doesn't support Fast Ethernet. IOU supports only the Ethernet interfaces. So if I click on start, you can see the IOU switch is started. See, it's basically same like you're working on the same VMware platform, but the difference is going to be there. It was not that easy to make your topologies, which this GNS3 makes a little bit easy and nice to view. And other plus point is, you can actually draw your, you can actually take your normal iOS images, normal iOS devices like 12.4, which I can also take from here, this 3700 device, which is running the old iOS platform. You can take that and connect it to the same environment and start. So to show you that it works fine, I'll take you to the switch first of all. You just need to double click on the device, or you can open the console from here. Okay, so I'm going to share this thing with you guys. I'll upload on that Google Drive folder so that you can download, and you can also simulate the same thing on your computer. So this is what the console is. This is the switch basically. So I'll open a console to R1, IOU2, R2, and IOU3. Okay, so this is what we are going to use for our labs. So if I go to R1 and say 150 interface address 0, IP address 10.1.123.1, I'm just going to put them into the same subnet, IOU2, interface E0/2, IP address 10.1.123.2/2, R2. I want to put IOU2, I put 2, so I put it here 3. Now the IP routing one, which I was talking with, which we already did yesterday. Right now, if we check show IP route, there's no route in the routing table of IOU3, right? So there's no route in the routing table of IOU3, because right now, if you check show IP interface brief, there's no IP address on any of its interface, right? If I go to interface E0/3, which is actually connected to the same Ethernet segment that R1, R2, and IOU2 are connected, and put an IP address 10.1.123.4/24, no shutdown. If you again use the same debug, which I told you yesterday, debug IP routing, this will give you the detail that how the changes are happening with your routing table. So when you go to the interface now, which was E0/3, and make no shut to this interface goes up, and when this interface goes up, you can see I'm adding those 3 information. Remember, to make an entry into the routing table, only 3 information are required: network, network mask and the next hop IP or exit interface. So you can see this debug says that 10.1.123.0/24 is via 0.0.0.0 because this is directly connected to me. This is not learned from someone else, so I'm not going to specify any next hop IP address. Connected routes always have a metric, means the AD value and the metric parameters as 0. You can see they are added to the routing table. You can see add 10.1.123.4/32 via 0.0.0.0 with connected metric of this. So you can see two things are being added. One is the subnet, one is the IP address. This is a about related to your new iOS 15. To check do show version, this is running that iOS version 15.4, and which has this new thing that whenever you assign an IP address to an interface, I'm not only going to install a route for the network connected to the interface, I will also keep the information as a L route for the IP address assigned on that interface. So now if you check show IP interface brief, I have an IP address assigned on this interface. So if you check show IP route, automatically a route gets installed in the table as directly connected. So this L is nothing but the IP address configured on the interface. So it keeps the information what is the exact IP address is configured on the interface. Now this connected route, this 10.1.123.0, the network information, /24 is what? Network mask information, prefix length information, and then Ethernet 0/3 is my exit interface information. So you see any entry, whether it's built up of RIP, EIGRP, OSPF, BGP, no matter which routing process I'm using to learn my routes, those routing entries are always going to have this three information. So right now, yes, any question? Yes, guys, are you guys up to me? Okay, so here you can see this IOU1 is getting some duplex mismatch because of this fast Ethernet mismatch. Now to test the connectivity, I can go to any of the device. Let's say I'm going to R1, and to show you that this platform works, I'll just try to make ping to 123.2, which is R2. Make ping to 123.3. 3.3, which is R3, that also works fine, and 4, which should also work fine. Yes, Sanjum, what question you have? Yeah, your mic is not working, Anjum. Yes, I'll show you IO3. Yeah, tell me, Anjum, what question you have? Yeah, there you go with the routing table. We have just one entry in the routing table. No, there are not 3 entries. There are only 2 entries. We have this connected route 10.1.123.0/24 via this, and I told you this 15.series iOS are going to have L route, which is for local, which is to keep the information. Yeah, L is for the IP address information. See, on this interface Ethernet 0/3, which you can see here, I have an IP address 10.1.1.123.4, which is directly connected to Ethernet 0/3. So this L route is just keeping the IP address information connected to Ethernet 0/3. And there are only 2 information, not 3. Where you see the third one? This, if you check this is just telling you that I'm using the class full network of 10, because when I'm using 10.1.123.0/24 or 32, these are subnetted routes. Means this is not the classful boundary, because whenever you see 10 is a class A IP address, and class A has a default subnet mask of /8, but I'm subnetting that and using the /24. So whenever you don't use the default subnet mask, you will always have here this entry telling you that how many subnets from that major network I'm using and how many masks I'm using from that major network. For example, if I go to interface E0/1 here, and if I put yes, I'll just show you one more thing here. If you go to interface Ethernet 0/1 and say IP address 192. Let's take a class B address 172.16.1.1, and I'm using 255.255.0.0. It's a class B IP address, guys, right? It's a class B IP address, and I'm using the default subnet mask, which is /16. If you check now, do show IP route. So don't get confused. That is nothing but telling you that you are not using the class full mask. You are using the subnetted entry. So right now, if you check, do show IP route, you can see this is telling me 172.16.0.0/16, and this is variably subnetted. I'm using 2 subnets from that and 2 masks, which is telling me information about 172.16.0.0/16, which is the network information, and 172.16.1.1/32, which is going to be my IP address connected to it. Okay, so that is nothing but the L route is nothing but the IP address that is you are assigning on the interface. Okay, so now this switching environment, which I was talking about, works fine. You can actually do most of your topologies on this based on all the devices like 3700, 7200, and the IoE devices. So coming back to our routing part here, the routing can be done in different ways. So remember one thing, routing is nothing but telling a router those 3 information, which is the network information, network mask information, and the third one, exit interface or next hop IP. So this routing can be either be done in a static way or the dynamic way. So static, either you can do the normal static or you can do the static default static, and in dynamic you can do either with IGP protocols, and you can also do EGP protocols. Now this routing, this static is nothing but a manual routing, and dynamic you can say a routing that happens automatically just by enabling some routing protocol. Okay, we enable the routing protocol and routing protocol does that job. But any type of routing, whether static or the dynamic, we are only worried about getting those 3 information, guys: network, network mask, and the exit interface or next hop IP. So here in IGP protocols, we are going to discuss 3 categories: distance vector, advanced distance vector, and link state. In EGP, we have path vector protocols. Okay, so you must be familiar with what are the IGP protocols and what are the EGP protocols from your CCNA classes. IGP and EGP. IGP stands for interior gateway protocol, and EGP stands for exterior gateway protocol. IGP are the protocols that works within the same autonomous system, and EGP are the protocols which works between 2 or multiple autonomous systems. So I'll come to those things after some time. Let's take in distance vector, we are going to talk about the RIP protocol, and in advanced distance vector, we will talk about EIGRP. In link state, we are going to talk about OSPF. And in path vector, there is only one routing protocol in EGP category, which is the BGP. For the gateway protocol, open shortest path first, enhanced interior gateway routing protocol, and the routing information protocol. So in CCNP routing messaging, our course, we are going to cover everything in much more detail. All these routing protocol we are going to cover. This all protocols are going to be a part of our CCNP routing messaging. So now, right now, we are supposed to do this normal static routing. First of all, we will start with normal static routing, then we will move to default, then we will move to these different routing protocols. So here, you just note it down, everyone.
Hi, Pawan.
Hello?
Pawan, this is Vikas here.
Yes, sir. Good morning, sir.
Good morning. How are you?
Yeah, I'm good, sir. How are you?
Fine. You know, when you speak, I don't know what, in the background there is a sound and the voice is not that clear. I don't know what is the issue.
Okay.
Yeah. So I'm not very sure what is the issue. You know, in the background there is some kind of noise coming. So what I've done is, after this class, I have just sent you one link with a
Mm-hmm.
different account of Zoom.
Okay.
Okay, and yesterday I did a lot of trials on that, and that server is installed in our Bangalore campus itself.
Mm-hmm.
So we'll try doing a conference on that, probably with the students also after this class, or now you can send a link to them, and let's see the difference.
Okay.
Because we are all going right away. Right now we are all going to California where the Zoom server is there, and then coming back to our own locations, which is taking a lot of latency.
Mm-hmm.
So if the trainer is closest to the main server, which is in our Bangalore office,
Yeah, yeah.
the trainer quality is going to be much more clear.
Yeah, true.
Because your bandwidth usage will be much more less, and latency will not be there.
Okay. Yes.
Okay, so I've sent you that. You can check on the Gmail and try activating that if you have any problem. Let's try sending that request after the class to the students for
Mm-hmm.
5-minute testing, because
Yeah,
the
sure.
students are in various part of the world,
Mm-hmm.
and they are the best judge to actually tell us that which one is better. Is this one better, or the one that we installed is better?
Yeah, sure, sir.
Okay, so just send me the link from that account, and then we'll connect back.
Okay. Do you want me to do it
Okay.
right now?
After the class, once the class is done.
Okay.
Okay,
Okay,
thank
fine.
you, man.
Thank
Bye.
you. Yes, guys. Note it down. Yes, Sayed, Ali.
I think this is the same we did as we did yesterday or day before yesterday. This table.
Okay, we have already done that. So
Yeah.
let's start now with the normal static routing. Start here. So let me take a new page for this. So in static routing, what as I told you on that table, that static is like normal static routing, which is like network, network mask, and exit interface or next hop IP. Okay, so these three information, as I've always been telling you, that these three information are basically required to route a packet and to make a route entry into the routing table of a device, of a router, right? So here, static routing. In static routing, we are going to manually define. We are going to manually define that which network and what subnet mask and what next hop IP and exit interface it's going to be. Okay, so in static routing, defining those three information manually is called static routing. Okay, defining these three information. As a network administrator, we will go to the devices. Here, let's say I'll go to R1 and I'm going to put a static route to reach, let's say R2's loopback, IO2's loopback, or R2's loopback, or R3's loopback. So that's what the static routing is. Now, here, one more thing here. Let's say I have this topology, okay, and with this topology, I need a diagram like this. R1, R2, R3, and R4. Guys, can you tell me how can I make this diagram using this topology? What do I have to do to make this? Because right now, you can see here in this topology, R1 is directly connected to R2, R2 is directly connected to R3, and R3 is directly connected to R4. Okay, but here in this topology, we don't have any direct connection between R1, R2, R3, R4 because they have switch in between. So to do this, we need to do. Sorry.
Remove the switch.
Remove the switch. That's not the solution, bro.
Mm-hmm.
I'm talking that from same topology. I'm talking about the same topology.
Add some more interfaces which connect to each of the routers.
Okay. No. I don't want to add any other cable. I don't want to add any other connection. I just want to make the same topology using the same Ethernet topology. So what I can do here I need to do something called logical topology, which we are going to build using the same physical topology. Okay. So here we are going to learn that how we can make physical same physical topology, how we can make this logical topology. Okay. Logical topology is nothing but how the data flow happens in the network, and physical topology how the devices are directly connected. So here I'm going to put, with the help of VLAN we can do it. I'm going to put here this R1 and R2. I will create a VLAN, and VLAN 12 I'm going to put into for the interface which are connecting R1 and R2. Then VLAN 23, basically this interface. Now we don't have two interface of that, so I have to take another switch here. So I cannot do for those two both. I have to take one more link here. So what you can do, let me tell you what I'm actually trying to do here. Let's say you have a rack where you have multiple devices. Okay. And we have one switch here and one switch. I have to take two switch in that. I only have one. So let's say we have switch number 1. This is how usually the racks will be connected. If you try to access the rack, the physical hardware rack, that will be connected in this manner. So each router has two connections going to two different switches, R1, R2, R3, and R4. Okay, so here let's say 0/0, 0/0, 0/0, 0/0 is going to switch 1, and we have the switch number 2 basically, which has 0/1 interface. Port number 1, port number 2, port number 3, going to the respective port on this port 3, 2, and 1. Okay, then we have a trunk between switch 1 and switch 2, a link between switch 1 and switch 2, which is going to be a trunk. Now, with this topology, guys, this 4 router topology, let's say I want the same topology. The devices are connected like this: R1, R2, R3, R4. I want to connect 0/0 to 0/0 of R2, 0/1 of R2 to 0/1 of R3, 0/0 of R3 to 0/0 of R4. So you can see R1 0/0 interface here. I need to make a connection to R2 0/0. So R1 0/0 is going to port number 1 of switch number 1. R2 0/0 is going to port number 2 of switch number 1. So I'm going to put these two interface into same VLAN. Let's say VLAN. That will make my connection between R1 and R2. Then R2 0/1, R2 0/1 is going to switch number 2, port number 2, and R3 0/1 is going to again switch number 2, port number 3. So I'll put these two ports into VLAN 23. That will make my connection between R2 and R3. Because you know that only the devices which are sitting in same VLAN can communicate with each other. Now R3 and R4, 0/0 both the side. So R3 and R4, port number 0/0 and port number 0/0 of R3 and R4, 0/0 and 0/0. This is gonna be, these two ports are going to be in VLAN 34. Okay, so when you do this, you don't need to change any of the cabling, right? The benefit is you don't need to change any of the cabling and you build your same topology. I have a document on this. If you are not very clear, I have a document. Basically, you should learn this into the CCN itself. But if you are not very clear that how to make it, because remember guys, when you practice these things on the real hardware rack is always going to be like this. So you should know how to convert, because no one is going to allow you to touch the cables, right? You're not allowed to remove the cables, and like when I asked you guys, you were saying that remove the cable, remove the switch, or plug another cable. So you're not allowed to do that. You can only make changes to whatever already exists over there. So here, if I take you to documents, I have a document on this, which is having the one example for converting this thing. Look for it. I will share it with you guys. Yeah. So here you go. So let's say we have this topology where I have 6 different routers connected to 2 different switches, and when you go down, we have these objectives. What are the interface going to different switches? Then from that physical topology, I'm telling in this topology that how to make this kind of topology, this logical topology from that physical topology you need to make. So I have gone through step by step that what are the VLANs you need to create on each switches and what are the interface you need to assign on those VLANs. So you can see the configuration part on all the switches. So you can just make it in the GNS3 itself, taking that IOU platform, and you can connect those switches, and based on what ports they are connected to, you can actually make the same topology following these documents. Okay, so this document has all the detailed configuration that you need to make on those devices to build your topology. Okay, I'll put this document on that drive and I'll share with you guys. Okay, so that will give you very good idea how to convert that. Okay, if even after that, if you're not clear, you just give me your questions. I'll help you. Okay, guys, everyone.
Okay.
Yes. Pawan, I think what is most important now is to configure this IOU and follow the document, and then come to the next class so that we can. It's easy for us.
Yeah. Yes. So what I'm going to do after today's class, I'll share all the things that are required to build up this first. Okay, so that is around 1 GB of file, because that has all the collections of all the iOS images. so that if you want, I can share only the single iOS, but I'll share the complete collection of all the different iOS images so that you can just change based on your requirement. So I'll send you the complete file. Just download it today, and in tomorrow's class, if you want, or I'll record a video maybe if I get time today or tomorrow. I'll record a video and I'll send you that video so that you can listen to it, and you can actually do the configuration on your own. So you can integrate the IoE platform to Day3 and can do these things, the topology that I'm doing. Okay, guys, clear?
Yes, thank you very much.
Okay.
Okay, so we'll stop for 5 minutes, huh?
Yeah,
Stop for
sure.
5 minutes and then we can. Hello? Yes, guys, let's start now. So,
Yes.
what I'm going to do here, this is C. If I try to build that topology, I can build connection from R1 to R2, then R2 to R3 to R4. But there is no connection because there is only single interface going to this. Either I can break it into multiple sub interface, then I can build that connection. But I'm not going to do into that. First, I'll give you this IoE platform channel. You make this topology, you make the setup. Then, if you are not clear with that document, then I'll tell you how you can do this physical to logical conversion. I'll take a separate portion of the class dedicate to this conversion. Okay. For now, I'll just take another diagram for our practice. So this is really nice, guys. This VMware platform, including this IOU into iOS. That's really nice because you have switching and routing platform on the same. So that's something that is really nice to work on. So I'm going to take three 7200 devices.
So on this web IOU and IOU are two different things, or just
No,
conversion?
that's same. We just call it with different names. IOU, IOL, web IOU, these all are same. Okay?
Thank you.
Yes, guys. So let me take R1, R2, and that's gonna be my R3. This IOU device is going to be my R3. Let's change the host name. R3. And the best thing about this IOU is, this VM platform is, that it doesn't take that many resources of your computer as your GNS3 devices take. So GNS3 takes more resources like memory and CPU resources compared to your this IOU devices. So I'm going to use here between R1 and R2 10.1.12.0 subnet. Then R2 to R3, I'm going to use 23.0. And I'm going to take 1.1.1.1 plus 24. So there will be a loopback on all the devices. So I'll take you into very much detail about static routing. So many things that we are going to do with static routing. Let me go to R1, R2, and R3. So let me quickly put the IP addresses on all three devices. Okay, so IP address configuration is done. Now, right now, you know that R1 is going to know about two of the network, this network and this network. Right now, if you compare here, R1 knows about two network, R2 knows about these three network, and R3 knows about these two network. Because by default, without doing any routing, all the routers knows only about the directly connected subnets, right? So here I'm going to use, you can see 1, 2, 3, 4, and 5 subnets I'm using right now in my this topology. So right now, if you check on R1, we can predict now, right? Because by default, router installs a route for its directly connected interface. So R1 is going to have 2 routes, which is 1.1.1.0 via loopback 0, and another would be 10.1.12.0 via fast Ethernet 0/0, right? This one and this one. Now R2 is connected to 3 different directly connected 0/0, 1/0, and loopback 0. So if you check, let me put duplex half so that it works fine with R3. Now if you check show IP interface brief, I have 3 interfaces and with an IP address. So I can see in my routing table I have 3 different routes: 2.2.2.0/24, 10.1.12.0/24, and 10.1.23.0/24. Okay, I have
What is the duplex half?
the duplex hub, because this is my fast Ethernet connection from R2 side, and R3 supports only Ethernet. So Ethernet, if you go to, did you understand?
Yeah.
So
Match the
yeah. So if you check Ethernet interface 0/0, this would tell you that this supports only half duplex. You should be able to see somewhere here. We don't see it here. We should be able to see in some of the output that Ethernet supports only half duplex and this fast Ethernet supports full duplex. That's why the mismatch is happening. Okay. So R2 is giving me this duplex mismatch thing. So 1/0, not half duplex, as with R3, Ethernet 0/0, half duplex. R3, Ethernet 0/0 as half duplex. So when I made it same, now we will not get those output. So I'll also
but still it works. It works.
duplex half. From both the end, I'm specifying. I'm actually hard coding that this is going to be half duplex. Interface 1/0 will tell you that duplex is half. Show run interface E0/0. This will tell you that duplex. This doesn't show you the duplex configuration. So this is you will see this kind of changes from your iOS platform with Genius 3 platform to your IO platform. Few command difference will be there. So your Genius 3 device is showing you that duplex on the running configuration, but this R3 is not. So here right now, coming back to our static routing, R1 knows about 111 and 10.1.12. R2 knows about 222, 10.1.12 and 10.1.23, which you check show IP route. It has 3 different routes, 1, 2, and 3. R3 knows about show IP route. R3 knows about 2, 10.1.23 and 333, because by default they are going to know only about the directly connected networks, which is 10.1.23.0 and 3.3.3.0/24. So here, when R1 doesn't know about 2.2.2 or 10.1.23 and 333, right now if you check here how many total number of subnets we are using in this topology, we are using 5 different networks, right? 111, 10.1.12, 2.2.2, 10.1.23 and 3.3.3.3. So if I want to provide complete reachability from any device to any device here, we have to put how many static route on R1? 3 static route, because I have to tell R1 to route the packet towards 222, 10.1.23 and 333, because these are the three networks that R1 doesn't know about. R2 knows about three of them, so R2 should only know about 111 and 333, and R3 knows about two of them. R3 should be able to route the packet towards these three networks, right? So
Yes.
I'm going to tell these three things manually. So the static route is nothing but telling those things manually to a device. So these three things. So the syntax of static route is going to be the command IP route. So then the first thing, network. Second thing, network mask. Third thing, next up IP or exit interface. Okay guys, this is the base syntax for the IP route configuration, the static route configuration. You can add down. So here on R1, if I go right now and try to ping 10.1.12.2, should I be able to ping 10.1.12.2? Do I have a matching route for this network? Yes, you can see here 10.1.12.0/24 is directly connected via F0/0.
Yes.
So if I make a ping, R1 should be able to ping R2. Yes, I'm able to ping. Right? Why the first ping gets dropped, guys?
R.
R process. To get the MAC address, we drop the first ping. Because of our process, that first ping is dropped. Now, after this, if I try to reach 2.2.2.2, do you see any route in the routing table for 2.2.2.2? No. So if you say
No.
2.2.2.2, this is not going to have any route for 2.2.2.2, and because of that, this is not able to route the packet towards 2.2.2. You say debug IP packet detail, enter, and then if you ping 2.2.2.2 with a repeat count of 1, means by default I sent 5 packet, I'm just sending now 1 ping packet. So right now you can see this is that packet is unroutable because I don't know where is 2.2.2. Just like when someone comes to you and asks, do you know about this destination? If you don't know, you say sorry. Same thing R1 is telling right now, sorry, I cannot route you towards your destination, which is 2.2.2, because I myself don't know where is 2.2. Same thing will be happening with 10.1.23.3, which is this subnet, right? If I try to ping this interface of R3, this is also going to tell me that packet is unroutable. And if I try to ping 3.3.3.3 using my repeat count of 1, that is again going to tell me that packet is unroutable. Because these are the three things which R1 has no idea right now from its router table, because every router by default knows only about the directly connected subnets. It has no idea about the subnets, the network which are not directly connected. Clear up to this point, everyone?
Yes, Pawan.
So what if I tell manually by going to that R1 and say IP route, what is the network? 2.2.2.0. I'm telling R1, manually I'm going to R1 and specifying those three things. That's what static route is. Slash 24, so 255.255.255.0. So I'm specifying first what the network is, 2.2.2.0, and the subnet mask is /24, and that should be the third information that you need to specify is the exit interface or next hop IP. So let's first do with the exit interface. You can use both with static route. I'll first do with exit interface, then we will do next of IP because they have different.
F is 0/0.
Yeah, true. So here from R1, guys, looking at the topology, we know that if R1 wants to reach 2.2.2.0, R1 should take F is 0/0 interface. And if R1 wants to pick up the next of IP, then it should be 10.1.12.2. Okay, because that's going to be the my correct next of IP. So eventually it has to find out what? Exit interface, right? Because exit interface, remember that IP routing process, in first process of routing, we actually find out what exit interface we are going to use. So here if I go to this and say my exit interface is F is 0, if you check show IP route with this configuration, you can write down guys IP route 2.2.2.0/24 F is 0. Okay, good. So when you do show IP route now, we have a static route for 2.2.2.0, which is shown up in the routing table as directly connected via fast difference. Okay, so if I try to ping, I should be able to ping right now. Can I ping guys this destination of 2.2.2.2?
No.
Okay, who is it?
Sayed.
Yeah, Anjum. Anjum, Janardhan, Ali, what's your call? Can we ping this address of 2.2.2.2? Okay, Janardhan says yes, Anjum says yes. What about Ali?
Yes.
Okay. Sayed, why you are saying no? I have a static route into my table. Remember, you just need to understand here, the routing is always two-way. Okay, routing is always two-way.
The other way is not configured, right?
But other way, why should I configure? Right now, when that's what I was taking here. When R1 is going to ping, when I'm gonna make a ping from R1 to 2.2.2.2, R1 will take. Remember, I told you yesterday that by default router takes the source IP address of a packet as the exit interface. Okay, R1 is going to take the source of the packet that it is going to send to 2.2.2.2 as the exit interface, which is 10.1.12.1. Does R2 know about 10.1.12 network? Yes, it is directly connected. So why not? Why I should configure the other way routing?
Directly connected. It's directly connected. Yes.
Okay. So if you try to ping this, enter, this will work fine, and which is working fine. You can see here, we are getting replies. Let me stop this debug and make this ping again. Okay, ping is happening fine. All the pings are happening perfect. Why? Because you can see the debug, when the debug happened actually, you can see what was the source of the packet. The source of the packet was 10.1.12.1 and that was going to 2.2 on fast different resolution. But if I try to ping 2.2.2.2 using my source IP address of 1.1.1.1, so this is important to understand. By default, when you don't specify any source, the router is going to take the source IP address as of the exit interface IP address. And when you specify this source, you can also specify that what exactly source you want to take. So I'm right now taking my loopback interface, which is 1.1.1.1. So will this ping work, guys? Will this ping happen? Say it.
I need to check the routing table.
Of whom? R2 or R1?
I'm pinging from R1. Yeah, I have to check from R1.
Okay, R1's routing table is this, and R2's routing table is this. Everything is in front of me.
So
R1
one is directly connected.
Okay, and check this on R2. Anjum says no.
Well, on router 2, it's not there.
Yes, true. On R2, because the packet when I'm going to send packet to 2.2.2.2 using my source of 1.1.1.1, the packet is going to reach to R2. So the one-way communication from R1 to R2 loopback is going to happen, but R2 doesn't know how to reply back to 111. The ping is not going to happen. So here we should configure static route on R2 for the response. So if I go to R2 and say debug IP packet detail, if I go to R1 and make that ping, what you will see here on,
I think the debug packet is.
so what R2 is telling, that the packet which is I'm trying to reply is unknown, right? When R2 is trying to reply from source of its own and to destination of 111, I don't know where it is, unknown. Because R2 doesn't know how to reach back to 111 because there is no route for 111. So do you understand, guys? Up to this point, any question you have? We're going to find out the class here today, and tomorrow will be complete static route dedicated class. I'll talk about different things in static, which might be very new to you. Okay, so we will learn so many different things in static routes, like static route, what are the pros and cons when you do exit interface and next of IP, that routing static route, remote next of IP, and tracking a static route with using SLA configuration. Different things we are going to do. Tomorrow's class will be dedicated to this topic. So in today's thing, guys, any question? I'll share the IOU and GNS3 thing, the new version of GNS3, and all the images, all the license file, and all those things. I'm going to share with everyone. I have your email. You might have got that yesterday's class note I shared with you. And
Yes, we got.
Even the video, first class video, Anjum, for you. I've shared it. Might have got it. Anjum, did you get that?
Yes, I think it was sent to everyone.
Yeah, I sent it to everyone, so you can just download it and you can listen to it and go through it. Get the first class today. Okay, guys. So, any question you have for me?
No.
No problem. Thank you very much.
Okay, guys. Thank you so much for joining.
Hey,
I think there was a.
do you want to test Vikas has told?
Yeah.
Sorry,
Do you want to test? Vikas was telling you to check some other Zoom URL, right?
Yeah. I'll send you. I'll check in my mail what exactly he was talking about. Then I'll send it to you, everyone, and then we will test that. Okay.
Okay.
Tomorrow we can.
Tomorrow you want to do it. Fine.
Okay, guys. Any other thing?
Okay, thank you.
Yeah. Thank you.
Okay. Thank you, guys. Bye bye. Take care.
Bye bye.